Okay, good afternoon, everyone. Is the screen visible?
Yes, sir.
Yeah. So let's start with our new topic, uh, which is the reduction formula. So before we get started with this, all the theory part and the things, I will just give you an idea, rough idea, what we actually mean by the reduction formulas. Why are these formulas so much useful? So our name of the module that we are learning here is integration tools. Okay, so we are going to learn different tools by which we can find out integrations very efficiently. And the first of those tool is the reduction formula. Say for an example, I want to integrate 0 to pi sine 2 pi sine raised to 99 times x dx. Uh, First of all, 0 to 2 pi, okay, and there is sine raised to 99x dx. Okay, looks quite familiar or something like that, but finding out is not that easy. Okay, so what we do is we actually make a pattern. Say for an example, I want to integrate from 0 to pi by 2 sine raised to 3x simply dx. You have the formula for sine of 3 theta actually. So you can use this formula, you can separate it, you can find out the integration. You can do it, but it will take some time. Similarly, if I have 0 to pi by 2 sine raised to 9x dx. Again, you can use UV rule, you can solve it, but it will take a long time. But if I give you a relation like this, say I n is equal to n minus 1 upon n in minus 2. Say I'm giving you this relation. So what will happen? Where n represents the power of sine, where n is the power of sine x. So what will happen? So you want to find sine raised to 9x. So that will be I9 is equal to 8 upon 9 I7. But I7 I can further reduce as 7 minus 1, which is 6 by 7 I5. But I5 again I can reduce as 8 by 9, 6, 7. Then this will be 4, 5. This will be 3, oh sorry, 3, 2. And this will be I0. Uh, I0. Now what? Am I correct? I0 or I1 it has to be? I5 का होगा I3 and I3 will come to I1. What is I1? I1 is equal to integral 0 to pi by 2 sin x dx. So integration of sin x is minus cos x, limits from 0 to pi by 2. So cos pi by 2 is 0, so this will be 1. So the answer is this. Is there anyone having doubt with this? So what I said is, if I have a relation like this, कि sine raised to n का integration will actually be equal to n minus 1 upon n integration sine raised to n minus 2. So using this relation, I have got the final answer without actually integrating anything. Okay, so what I have done is I have reduced the power of sine. So I have made a relation between sine raised to n and sine raised to n minus 2 and used it to find out the integration. So this technique is called the reduction formula, and this is not particularly just about sin x. The same thing happens for cos x. You can also make a reduction formula for tan raised to n. So these all combinations are possible. Even the combination of sine raised to n and cos raised to m, we can make a reduction formula. So this gives the answer for any of the integration very efficient. And how we do that, that we are going to see in the further study. Fine. So let's come to this. So look, what I'm doing is I have in is equal to integration sine raised to n of x dx. So please concentrate on this n. What does this n represent? In, the suffix of I, that represents the power of sine. There is a relation between these two. Okay, so whatever is the power, that is the suffix. So what we are going to prove is this relation. So in is equal to, we'll get this. So you can see that there is a relation between in and in minus 2. And when we give the limits, everything will change. So let's not waste time in this reading all of this, but let's come to the calculations. So integration sine raised to n of x dx, right? So sine raised to n I can write as sine raised to n minus 1x into sine x. Uh, so the reason behind writing this is that I am trying to use the Liet rule, and how I'm choosing sine raised to n minus 1 as u and v as sine x. Anyone? Any logic on this? Why the first term is u and second is v? Anyone? We are going to encounter this kind of thing in many examples. So I want to make sure that you understand why the first term is u and the other one is v. Anyone? Any thought on this? Yes, Siddhi? Yes, Umed?
Sir, if we consider just the sin x function, it
Yes.
is uh, it is purely trigonometric. But if we consider sine raised to n minus 1,
Huh.
it involves exponential component also, and according to Liet rule, exponential has to be the last.
Okay. Exponential component is there. Yes. Okay. Fine. The logic I want to give is that the there is this u and v differ actually only by this. So you take the derivative of u and you have integration of v, right? So these things are there when you are using uv rule for integration. So you should be able to take the derivative of u and you should be able to integrate v. So whereas in this example, when I take integration of sine raised to n minus 1, it will again come back to the same expression, and it will become difficult for us. Whereas in this case, the choice sine raised to n minus 1, the derivative will lead to this term. So sine raised to n minus 1x minus, so u integration of v, this is integration of v minus integration, the derivative, you can see that n minus 1 sine raised to n minus 2x, by chain rule derivative of sine x, this becomes cos x. So this term is du by dx and the integration of v, the total integration. So later what we have here is this term minus sine raised to n minus 1x cos x plus n minus 1, we can multiply these two cos and we get cos square x. The minus sign makes this plus. So now cos square x I can write as 1 minus sine square x. You can see this. Okay. And there is this n minus 1. I hope everything is clear up to this. Later we open the bracket. In is equal to minus sine raised to n minus 1x cos x. The first term as it is. The second one, n minus 1 integration of sine raised to n minus 2x. Then minus of n minus 1 sine raised to nx. So you can see that what we have here is integration sine raised to nx, which is nothing but in. Whereas here we have integration of sine raised to n minus 2. So this turns out to be n minus 2. So what we are going to do is we'll simplify this. In the next page, so what we have got is in equal to minus sine raised to n minus 1 x cos x plus n minus 1 in minus 2 minus n minus 1 in. So collect the coefficients. So n times in equal to this. Now I will divide n and we have got this. The same thing can be done with cos and you'll get the almost same expression. I said almost same. The only change is you have sine raised to n minus 1 x there and you have cos raised to n minus 1 x. And there is minus sign with this, here you don't have. So the same thing can be done with cos. That will be a good exercise, and in some theory papers this derivation has been asked. So you get the same thing. But you can see that there is not a lot of conclusion here. So I will make a short small change in this. So I will define in as integration 0 to pi by 2 sine raised to n of x dx. What's the change? When we derived this formula, our in was integration sine raised to n of x dx. This integration was indefinite integral, whereas I have made it definite. What change we are going to get in this? So we'll get in equal to minus sine raised to n minus 1x cos x divided by n. Limits are 0 to pi by 2 plus n minus 1 upon n integration sine raised to n minus 2x 0 to pi by 2 dx. What's the formula? Can someone tell me? In will be equal to, if the limits are given 0 to pi by 2, you just have to put the limit. What's happening for the upper limit? At pi by 2, cos pi by 2 is becoming 0. When you put the lower limit, sine 0 is 0. So the first term completely, this term becomes 0. What is the second term? N minus 1 upon n I n minus 2. So this is the same relation that I gave you earlier. So we have made a relation between in and in minus 2. Note that your limits are finite and those are 0 to pi by 2. So the same relation, even if you put that here in this, in equal to cos raised to n minus 1x, even if you put 0 to pi by 2 in this case, at pi by 2 first term will become 0 and 0 second term will become 0. So even for cos, if in is equal to integral 0 to pi by 2 cos raised to n of x dx, even then in which you will get, that will be n minus 1 upon n in minus 2. So you can see that the reduction formula for the finite limits 0 to pi by 2, our reduction formula is same. Okay. So this relation you have to remember. Whenever in our integral calculus, even in M3, whenever you will have to find the integration, you should be able to use the reduction formula very efficiently, because you can see that it is a very strong result. You don't have to do any integration. Directly you get the answer for an integration in a numeric answer. Look, whatever I have done earlier, the same thing is done here for 0 to pi by 2 sine raised to n. So I'll directly go to the next page as it is already explained, and we get this. So see here. So what we have got is in is equal to n minus 1 upon n in minus 2. So in minus 2 I can write as n minus 3 and so on. So we get this. So we can keep doing this up to we get I1 or I0. Okay, so if we keep on reducing the above formula, what we get is in is equal to n minus 1, then we'll have n minus 2, n minus 3, and we will go on up to I0. We'll get I0 only if n is even. And if n is odd, then the last term that I will always get is I1, because I am subtracting 2. You can see that after every step we are subtracting 2. So in is related to n minus 2, n minus 2 is related to n minus 4, n minus 4 is related to n minus 6, and it will go on reducing. So when you are subtracting an even number, the possibility is at the last stage you will get I1 or I0. But the value of I1, we have seen that it is 1, and I0, the answer is pi by 2. So I0 is integral 0 to pi by 2 sine raised to 0x dx to pi by 2. It is I1 integral 0 to pi by 2 sine raised to 1. So this we have seen earlier. Okay, so these are the formulas. The same formula will work for the cos. But I would like to give you the way by which you can actually remember. So I will write down this remark. If you are noting this down, you can make the remark over here. The remark is, if in is equal to integral 0 to pi by 2. Beta Omkar, will you mute yourself? So if in is equal to integral 0 to pi by 2 sine raised to n of x dx, then how do we go ahead? So n minus 1, n minus 2, n minus 3. So this is a sequence that you have to, follow. You start with n, you go on reducing. Look, this is the way you are proceeding. This complete diagram has to be followed. And what stage we will reach up to? So if we get 1 at the end, and if we get 0, then the answer will be pi by 2. So we'll quickly solve some. So if I want I7, then it's 7, 6, 5, 4, 3, 2, 1, right? If we have I8, then what will be the answer for this? 8, 7, 6, 5, 4, 3, 2, 1, and last I0 is pi by 2. So this is how we remember. The same thing works for the cos also, as we have earlier seen that the formula is same for sine as well as cos. Is anyone having difficulty up to this? Please ask. If not, then I'll go ahead. Nothing. So we can see here integral 0 to 5 pi by 2 sine raised to 5x. As the integration 5, 4, 3, 2, 1. The answer is this. So cos raised to 8, start from 8. 8, 7, 6, 5, 4, 3, 2, 1, and I0. I0 is 5 by 2. So you can multiply here. So look, your integrations have become easier. So I will write down the remark here. Formula for integral 0 to pi by 2 sine raised to n x dx is equal to integral 0 to pi by 2 cos raised to n of x dx. The formulas are same. Technique is same. Start with the power, go on reducing it. If the last term is 0, put pi by 2. If last term is not 0, then put if the last term is 1, then I1. So see here 0 to pi by 2 sine raised to 4. So 4, 3, 2, or 1, I0. The answer is 3 pi by 16. 0 to pi by 2 cos raised to 7. Power is odd. Go on reducing it. 7, 6, 5, 4, 3, 2, I1. I1 is 1. Okay. Some definite integral properties I want to recall here. The reason is whatever reduction formulas that we have seen till now, those are like this. So those are simply from 0 to pi by 2 sine raised to nx. So limits are 0 to pi by 2. So I should be able to find out the integration where we have 0 to pi sine raised to n of x dx. I should be able to find out this. I should also be able to find out if I have 0 to 2 pi. So all these possibilities I want to explore, and the reason, I mean, the way I am going to find out those formulas is by using this definite integral properties. The first property, integration 0 to a f of x dx, is actually equal to 0 to a f of a minus x dx. Quite easy property to remember. Next property, integration minus a to plus a f of x dx is equal to integral 0 to a f of x dx plus 0 to a f of minus x dx. Again, this is the property that you have seen in your 12th standard, which helps you to directly give the answer for even and odd functions. Just for a revision, if f of x is an even function, if f of x is even, then integration minus a to plus a f of x dx, I can write it as is odd, then no one. Yes, what is the answer for this?
Sir, for odd 0.
For odd, it is 0. Because what will happen is this f of minus x will become minus of f of x, and both terms will become same. They will cancel out each other and it will become 0. So if f of x is even, then this term will become f of x. So what we get is 2 times
2 into
in 0 to a f of x dx. Last and a very important property, 0 to 2a f of x dx is equal to 0 to a f of x dx plus integral 0 to a f of 2a minus x. I'll just give an example over here to uh, see the use of this property, and we will use this property in each and every uh, deduction. Say we have the formula for 0 to pi by 2. Okay, so I'll take the formula 0 to pi sine raised to n of x dx. By this property, pi is nothing but, so pi is nothing but 2 times pi by 2. Okay, I've written this to so that you will be able to relate this with this property. So what we will have, integration 0 to pi by 2 sine raised to n of x dx plus integral 0 to pi by 2 sine of 2a minus x. 2a is pi minus x raised to n dx. Now sine 180 minus theta. Yes, anyone? Sine 180 minus theta.
theta.
Sine theta.
Minus sin theta.
Sine a cos b minus cos a sine b. Cos pi is minus 1, so it will become sine x, I guess. Yes or no? Sine 180 minus theta is
Sin theta.
sine theta. The first, so this will be integral 0 to pi by 2 sine raised to n of x dx plus integral 0 to pi by 2 sine raised to n of x dx. So this is equal to 2 times integral 0 to pi by 2 sine raised to n of x dx. किसका फॉर्मूला है ये? 0 to pi sine raised to n of x dx I can write as 2 times 0 to pi by 2 sine raised to n. Now I have the formula for 0 to pi by 2 sine raised to n of x dx. Just now we have seen what was the formula? n, n minus 1, n minus 2, n minus 3, so on, whatever, I don't care about it now. So what I have done is I have actually found out the formula for 0 to pi sine raised to n of x dx by using this property. So the same thing I can do for 0 to 2 pi. Can someone tell me what will happen for 0 to 2 pi? A good exercise. You have 2 minutes. See what you will get. You will get sine. You will have the formula for 0 to pi here. 0 to pi. 0 to pi. You'll have sine 2 pi minus x. Sine 2 pi minus
0.
theta. 0 when sine 2 pi minus theta is,
Minus sin theta.
so minus sine
Sir, we will get the same formula again.
raised to n dx. What about this n? So things are depending on this n, minus sine x raised to n. So if n is odd, then both will cancel out each other and answer will become 0, right?
Yes.
Yes or no?
Yes.
Yes. So if n is even, then you will get 2 times 0 to pi. 2 times 0 to pi sine raised to n of x. This is what you will get. So look, using just one property, what you are able to do, you are able to reduce any of the interval to the 0 to pi by 2, and later 0 to pi by 2, what I can do is I can find out using the previous formula. Again, you can see that the 0 to pi sine raised to n of x I can write as 4 times 0 to pi by 2 sine raised to n of x dx, right? So 4 times this formula. If n is even, note that if n is odd, n odd, then answer will directly turn out to be 0. So I'll go to the next page so that we can see these things actually here. So see, I have just proved this result, the first one, 0 to pi sine raised to n. We have seen this proof. So 2 times 0 to pi by 2 sine raised to n of x dx. So what happens for cos? Let's prove this result. So what we have, in is equal to integral 0 to pi cos raised to n of x dx. Let's use that property again. We'll have 0 to pi by 2 cos raised to n of x dx plus integral 0 to pi by 2 cos, what I should write here, pi minus x total raised to n dx. Cos 180 minus theta, if you don't remember 180 minus theta, or you cannot find out,
Minus cos theta. Minus cos theta,
Cos.
sir.
minus cos theta. So 0 to pi by 2 minus cos x raised to n dx, right? So if n is even, odd, if n is odd, then minus cos x raised to odd number will become minus cos raised to n. So 0 to pi by 2 cos raised to n of x dx, this will be 0 to pi by 2 minus sine cos raised to n of x dx. So these two things will cancel out and answer turns out to be 0, right? If n is even, if n is even, then what we get is 2 times 0 to pi by 2 cos raised to n of x dx. So you can see that, I guess now we are using the same property again and again to derive these results. So we get 2 times 0 to pi by 2 cos raised to n of x dx. If n is even, it is equal to 0 if n is an odd. Similarly, 0 to 2 pi, just now I also proved this result. So first it became 2 times 0 to pi, and then from 0 to pi, what I will do is I will reduce it to 0 to pi by 2. I hope this is clear. If you have any difficulty in this, please ask. So 0 to 2 pi I will write as 4 times 0 to pi by 2 if n is even, and it will become 0 if n is odd. So in maximum cases, wherever you have odd number, you get 0. Only in 0 to pi sine raised to n, you don't depend on n. Similarly, the last one. Is there anyone having difficulty in this? No response. I'll consider there is no difficulty. So I'll go ahead. See the examples now. So what we have, 0 to pi sine raised to 8x. We know that we have the formula for 0 to pi by 2. So I will reduce this first. So 2 times n के ऊपर depend करता है 0 to pi sine raised to n? No. It is independent of n. So 2 times 0 to pi by 2 sine raised to 8 of x dx. Now 0 to pi by 2 sine raised to 8. 8, 7, 6, 5, 4, 3, 2, 1, or I0. What is I0? I0 is pi by 2. Then 0 to pi cos raised to 5x dx. You can see that. I'll go to the previous page. 0 to pi cos raised to n. The answer is 0 if n is odd. So using this property, 0 to pi cos raised to 5 x dx, answer is 0. Cos raised to 7, 0 to 2 pi. So I'll go to the property again. So 0 to 2 pi cos raised to n. The answer is 0 if n is odd. So even for 0 to 2 pi n is odd, answer 0. The next example, 0 to 2 pi sine raised to 6x dx. Now power is even. 0 to 2 pi 4 times 0 to pi by 2 sine raised to 6. But we have the formula for 0 to pi by 2 sine raised to 6. 6, 5, 4, 3, 2, 1, 0. 4 times. So I'll show you the property for sine raised to n, 0 to 2 pi. So you can see that here in this property, 0 to 2 pi sine raised to n. If n is even, then what you can do is you can write it as 4 times 0 to pi by 2. Okay, so we have used that property over here. The next case is for the combination sine raised to m cos raised to n. So you have two powers here now. So you can see that there is m and there is n. So the proof, I'll just give you the outline of the proof. So what we do is we consider Imn, where m represents the power of sine and n represents the power of cos. So 0 to pi by 2 sine raised to m of x cos raised to n of x dx. Again, there is a condition. Both m comma n has to be greater than or equal to 2, or else this formula won't hold. Okay, so it has to be mentioned somewhere. And what is the answer to this integration given by? So you take the power of sine, what you are subtracting every time, and you take the power of cos, again you are subtracting something. What do you observe? What do you observe? What you are subtracting here from the power of sine? Sahil?
Yes, sir.
Yes, what you are subtracting from the power of sine in this?
Um, sir, just a minute.
Chirag? Therefore, later when you will sit for studying, you won't be able to remember anything. Please participate in the discussions. So what do we see here is that we are actually subtracting odd numbers. Okay. So I'll get back to this. So you take the power of sine, you subtracted 1 in the first term, you subtracted 3, 5, and so on. You go up to 1 or 2. Look, you cannot include 0 or negative number here. So you go on subtracting odd numbers. Similarly, you take the power of cos, you are subtracting odd numbers from this 1, 3, so on, and in the denominator you add the powers m plus n, and you go on subtracting even numbers. So look, 2 is subtracted, 4 is subtracted, and so on. It will go up to 1 or 2, and there is a multiple k, but this k depends on the powers. So if both are even, then the value of k is pi by 2. If any one or both are odd, then the value of k has to be 1. This will be very well understood if I immediately take an example over here. So if I have 0 to pi by 2 sine raised to 3x cos raised to uh, 6x dx. What have we need to do? Take the power of sine, go on subtracting odd numbers. 3 minus 1 is 2, and then that's it, nothing else. Then you take the power of cos, subtract odd number, 5, 3, 1, divide, add both of them, 6 plus 3, 9, and go on subtracting even numbers. So 9, 7, 5, 3, 1.
1.
And then we have to multiply by k, but k both are even, then pi by 2, otherwise 1. So this is the integration. Whatever the answer is, multiplication can be done. On the next page we can find some examples here. So sine raised to 4 cos raised to 6. In the numerator, take the power of sine, subtract 1 and 3. So 3, 4 minus 1 is 3, and then 1. Power of cos, which is 6, subtract 1, which is 5, then 3 and 1. In the denominator, add both of them. 6 plus 4 is 10. Go on subtracting even numbers. 10 minus 2, 8, 6, 4, 2. As both of them are even, I have multiplied by pi by 2. So if I have 0 to pi by 2 sine raised to 5x cos raised to 8x. So 5 minus 1, 4, 5 minus 3, 2. Then power of
Sir,
cos
in
is
the second one is the n wrong because it is given 6 and in the above the cos is 8.
uh,
In the
this one
second,
you're
sir.
talking about.
Yes, sir. The m is
Yes, yes,
5.
it
This is
is wrong.
correct.
It has to be 7. There has to be 7 first, as the power is 8. है ना?
Yes, sir.
Yes, so 7, 5, 3 and 1. In the denominator,
Will be
8 and
13.
5, it is 13. 13, 11, 9, 7, 5, 3 and 1. As one is even, other is odd, multiple is 1. Okay.
Yes, sir.
So there are similar properties that we have seen earlier for sine raised to n and cos raised to n for 0 to pi. So if we have 0 to pi, the above properties can be used again. So 0 to pi sine raised to m cos raised to n. So this I can write as 2 times 0 to pi by 2 sine raised to m cos raised to n. So this will be possible if n is even. Look, in this case you will have to concentrate on what is n, what is the significance of n, and you can write it as 2 times 0 to pi by 2 if and only if the power of cos is even. I'll just recall what created the problem. cos of 180 minus theta. So cos 180 minus theta actually becomes minus cos theta. Okay, and that's why in this case 0 to pi by 2 sine raised to m cos raised to n, the power of cos will play a major role. If it is even, then I can write as 2 times. If it is not, then the answer is 0. Similarly for 0 to 2 pi. So for 0 to 2 pi sine raised to m cos raised to n, this is 4 times 0 to pi by 2. If both are even, then I can write as 4 times 0 to pi by 2. If any other case arises, then the answer is 0. So there are some simple examples on this. So 0 to pi sine cube x cos raised to 4x. What we need to concentrate on, power of cos. Power of cos is even. So I can write this as 2 times 0 to pi by 2 sine cube x cos raised to 4x. We have the formula for this. So that is 3 minus 1, 2. 4 minus 1 is 3. 3 के बाद में आएगा 1. In the denominator, add both of them. 4 plus 3, 7, 5, 3. 1 is even, other is odd. So multiplied by 1. This is our answer. In the next case, देखो 0 to pi cos की power क्या है? Odd है. Answer is 0. So 0 to 2 pi, if both are even, then I can write this as 4 times 0 to pi by 2 this. Now we have the formula for sine raised to 4 and cos raised to 6. So 4 minus 1, 3. 6 minus 1, 5. 3, 1. Add both of them. 10, 8, 6, 4, 2 multiplied by pi by 2. So that is all about sine raised to n, cos raised to n, and their combinations. So in tomorrow's lecture, what we will see is we will actually derive some of the reduction formulas for non-trivial functions like cot raised to n, log x raised to n, and which are kind of theory examples and can be asked in MCQs in some other way. But those are very much important. Today's was quite easy one because you are